recording 6.4 a little bit differently for the front side because I want to show you how you can use your calculator to help you along on this, to be more efficient with your time, and also to avoid some silly mistakes. In this question, it is a motion question. I'm given the velocity of a particle right here, and I'm given a single position that says s of 0 equals 10. I'm asked to find all values of t on the interval 2 to 4 where the speed is 2. So you have to know what speed is, and what we've learned is speed is the absolute value of velocity, so I want to know where that speed is 2. An absolute value equation breaks down into two regular equations. One of them is where that velocity is 2, and the other one where the velocity is negative 2. Because I could have a 2 inside the absolute value, that would give me a speed of 2, or I could have a negative 2 inside the absolute value symbol, and that would also yield a speed of 2. So now I'm trying to solve these two equations, and this is my velocity right here. What you do not want to do is solve this by hand. Any equation can be solved with this method I'm about to outline right now. What you want to do is go to your calculator and type the left side of the equation into y1 and type the right side into y2. And I want to type this velocity equation into y1 right from the very beginning of this problem. Anytime I need to use it, I'm just going to call up y1, and it'll avoid any key punching errors, and it'll make me go faster because I don't have to type this thing in multiple times. If I want to know where y1 equals y2, I'm going to take a look at the graph. Before I do that, I'm going to go to my window setting. I'm going to make sure that my window is set to reflect what I'm told right here, so from 2 to 4. And then I hit graph, and my answer is sitting right here at that intersection point. To find it on an 84, I hit second, calc. I'm after an intersection point, so number 5 makes sense. First curve, hit enter. Second curve, enter. My guess, hit enter, and it's going to return that intersection point of 3.127. That's the truncated answer. If you want the rounded answer, you could round it to 3.128. Either one would be accepted. I also need to find where my velocity equals negative 2. So I'm just going to go back to y equals, and I'm going to change y2 to say negative 2, and I'm just going to repeat this process. Hit the graph. I'm going to be after that intersection point of velocity and negative 2. So again, second, calc, I'm going to choose number 5, and then I'm going to hit enter 3 times. And my second place where the speed is 2 is 3.473. On the next part, it says to write an expression involving an integral that gives position. So that is my keyword, position. I'm going to use that position formula. So I'm going to pause and just answer this part of the question right now. So I know to find position, I start with a known position. It's going to require me to come up here, and what I know is that s of 0 is 10, so I'm going to use s of 0 plus. What comes next is the integral with these as my limits from 0 to t. Now, because I'm using t as my upper limit, when I go to write my velocity equation as the integrand, I can't use the t. I have to switch up that variable, and I'm going to call it x. T for this equation here is the time that's going to be replaced for that upper limit. And the next part of the question says, okay, now I'm going to use this to find the position when t equals 5. So in this equation, I'm going to replace the t with the 5. So s of 5 equals 10 was that position at 0, plus the integral from 0 to 5, just replacing that upper limit with my t value of my velocity. And then from here, you don't have to do an antiderivative by hand. If you have your calculator and you have a definite integral to do, it is understood that you're going to do that on your calculator. So I'm going to go to my calculator here, get to my home screen. I'm just going to type this in. 10 plus math 9 is where you're going to find that integral. What I want to go here is that velocity equation, which is that negative 2 plus blah, 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 blah. I've already typed it into y1, so just hit the alpha key and then the F4 menu, and it'll pull up that y1 for you. and then dx. And it takes a minute to do it, but it tells me that my position is 9.207. So when you're doing this, you want to make sure that you write the integral on your paper, but then let the calculator evaluate that integral. On the next part, it wants to know, I'm being asked to find the times when the particle changes direction. So I know a particle changes direction when the velocity equals 0 and changes sign. And I have my velocity equation sitting here in my calculator. So I'm going to get rid of that -2 that I used in part A. I'm given a time interval here from 0 to 5. So on my calculator, I'm going to set my window to reflect that time interval from 0 to 5. And then when I hit graph, this is my velocity graph, and I want to know where this is equal to 0 and changes sign. And I can see it does that in 2 places, one here and one here. I just have to find what those times are. So I'm going to go second calc. These are zeros for this graph, so number 2. When it's asking left bound, I'm going to position my cursor to the left of the 0 and hit enter. Couple clicks to the right, so I'm to the right of it. Hit enter. Guess, just hit enter one more time. Gives me one of my zeros is 0.536. So 0.536 is one of them. And then the other one, following that same process, second calc 0. Position the cursor to the left. Hit enter. A couple clicks to the right. All I'm doing is defining an interval for my calculator to search for the 0, and that's where that 3.317. You could call it 3.318 if you wanted to round it. Either answer would be accepted. In part D, I'm asked if the speed of the particle is increasing or decreasing, and what we know is speed is increasing if velocity and acceleration have the same sign, and decreasing if they're different. So I just need to find that information. My time in question is t equals 4. So I have to find my velocity at 4. So keep in mind that my velocity is stored in here. So my velocity equation is right there into y1. So what I want to do is y1 of 4. So I alpha f4, pull up y1 of 4. Tells me negative 11.475. And then I want to find my acceleration, which is the derivative of velocity. So on my calculator, I'm going to go math number 8 is how I'm going to pull up that derivative. I'm doing the derivative of y1. So alpha y1. My x that I want to plug in is a 4. And it gives me that negative 22.295. I can see that they're both negative, so that tells me that my velocity is increasing because V of 4, A of 4 have the same sign. So I just sum it up. Make sure that you don't just say this. Make sure you give specific information about this problem as part of your reasoning. What you've just experienced in those 4 parts is one full FRQ that you could expect to see on an AP exam. We don't always get those same 4 questions. You could be asked anything. So I just added a few more questions just so you could see a variety of things that might be asked. This total distance traveled question is a popular one. What you're going to want to make sure that you do is show that total distance traveled integral, which is that. You don't have to write that whole velocity equation. You can just call it V of t because that's what it's called above. And now you just have to get this into your calculator. So I'm going to pull up my integral from 2 to 4. My absolute value is math right arrow. I'm not typing in that long velocity equation. I'm simply going to pull up my y1 again and my dx. Sometimes it takes a few seconds for this to actually calculate the answer. And I get 9.253 truncated or 9.254 if you want to round. The next question is average velocity. You want to think about that as saying average value of velocity, and then just take an average value approach to it. So my average value integral is 1 over b minus a, make sure you put the actual numbers there, times the integral of the velocity. If I'm doing average velocity, make sure that what you're putting here is actually velocity. And then you just type that into the calculator. 1 divided by 2 and math 9, and you're just typing in this integral. And again, y1 is where I have stored that velocity equation, and it's going to give me that 1.120. You don't actually need to write the 0. It's okay to do that, but you don't have to. And then average acceleration, it's going to start out looking the same. Average value of acceleration. So if I want average acceleration, what's going to go here in my integrand is acceleration. The calculation of it is a little bit different because I have a velocity equation that I'm working with here. But what I know is that the antiderivative of acceleration is velocity, evaluated along those limits. So I'm just going to calculate this into my calculator. So 1/2 parenthesis. For v of 4, I'm going to type in y1 of 4 minus y1 of 2. And you get that final answer, and that is your average acceleration. Make sure on any motion problem or any calculator problem that you have, make sure that you show what you're actually putting in the calculator. So not just an answer, but actually what it was you were putting in the calculator to get that answer. Whether it was an equation that you're solving, if it was an integral that you were using your calculator to evaluate, or if it was a derivative that you're using your calculator to evaluate. You have to make sure that that shows up on your paper. Our second example here is what a motion problem would look like with a table. It's from the 2015 exam. It's question number 3. There is no calculator allowed on this one. And what I have to work with is a table of velocity values. So Joanna is jogging, and her velocity at certain times is given in this table. And I'm first asked to estimate v prime of 16, and this is v. So I'm asked to approximate the derivative of v at 16. So this is where I find where 16 would fall, and it would fall in between the 12 and the 20. So I'm going to work on this interval right here, and I'm going to use an average rate of change to approximate this instantaneous rate of change. This is actually no more than y2 minus y1 over x2 minus x1, which is slope. I don't actually have to simplify this, but if you did, you would get an answer of 5. The question doesn't say anything about giving units, so I don't have to give units. If you chose to give units, the 240 and the 200, their units are meters per minute, and the 12 and the 20, their units are minutes, which ends up being meters per minute squared, which is an acceleration unit. And I know when I do v prime, I'm finding acceleration, so everything just matches up. In part B, I'm asked to explain the meaning of this integral in the context of the problem. So when it says in the context of the problem, what you don't want to say is just, oh, I'm doing an integral from 0 to 40 of absolute value. You want to say what it means as Joanna is jogging along the straight path. You should recognize the absolute value of velocity is an integrand as being your total distance traveled. So I would say that this is going to represent the total distance that Joanna has jogged. This has also asked me to use correct units. So here's my total explanation. It's the total distance Joanna jogs in meters. So that is the units part. From t equals 0 minutes to t equals 40 minutes. Whenever you explain an integral, you have to include 3 things. Number 1, what it is, that's the total distance. Number 2, the units, that's the meters part. And then number 3, you have to say what the limits mean in the context of the problem, and that is just her time interval. I'm also asked to evaluate that total distance traveled using a right Riemann sum with 4 subintervals that are indicated in the table. So 0 to 12 is 1, 12 to 20 is 2, 20 to 24 is 3, and 24 to 40 is 4. I'm going to make sure I pull up these numbers on the right side. And also because it's absolute value, I need to make sure that I take this negative 220 and I'm going to take it as a positive 220 when I do my right Riemann sum. This is my right Riemann sum here. Notice that that 220 is a positive right here. You don't have to actually simplify this if you don't want to, especially since you don't have a calculator. If that's your thing and you're good at it, you can bring it down to a 7600. But I would advise to just stop it right here. In part C, we have Bob, who's riding his bicycle. We are given Bob's velocity as this equation, and we're asked to find Bob's acceleration at t equals 5. We know that acceleration is the derivative of velocity, so I'm going to start by finding the derivative of b. Make sure to write your b prime of t equation first, and then we're just going to substitute a 5 into it. Here is my b prime of 5. I can calculate if I want to, but you don't actually have to. You could leave this b prime of 5 like this. It is an acceleration, so I put an acceleration unit on that. There's nothing in the problem that's asking me to find the units, so that actually, I don't need to write it, but it's good to know that's what an acceleration unit looks like. In part D, I'm asked to find Bob's average velocity. And again, just think of that as saying average value of velocity. So we're going to start by taking an average value integral. So it's 1 over b minus a times the integral from 0 to 10 of Bob's velocity, which is given up here as b of t. Without a calculator, I'm forced to do this antiderivative by hand, but it's an easy one. It's just a power rule. Once you plug those limits in, you don't actually have to calculate. You can give that as your final answer. If you did calculate that, you would end up with 350. Those first 4 parts represent a pretty standard FRQ. I've added a few extra questions at the end just so you could see different types of questions. In part E, I'm asked to find the exact value of this integral, 1 over 40, and the integral of 0 to 40 a of t dt. Because I'm given a table of velocity values to work with, I need to get this to be velocity, so the antiderivative of that acceleration is going to be velocity. Antiderivative of acceleration is velocity, and then I plug in my limits, so v of 40 minus v of 0, and now I can just go to my table and look up these values. I get 150 over 40, and that is my exact value of that integral. There's another part of the question that says explain the meaning of this integral in the context of the problem. So there's 3 parts that need to be shown in that explanation. Number 1, what it is. Number 2, the units. And number 3, what the limits mean in the context of the problem. What you should recognize when you see this, that 1 over 40 makes this an average value problem. So when you see that fraction out in front that matches the limits, this is an average value, and it's the average value of whatever you have sitting here in the integrand. So this is going to be an average acceleration. I also need to provide units on this explanation. This is acceleration, so I'm going to say in meters per minute squared. And the third component is to say what these limits mean in the context of the problem, and that is just my time interval. And I have my 3 parts. What it is, average acceleration, my units, meters per minute squared, and my limits are showing up in my explanation. The last question wants to know how many times does that velocity equal 220? I'm told this is a differentiable function which implies continuity. That's an important point for me to establish because I'm going to use the IVT, the intermediate value theorem, in this problem. Looking for where the velocity equals 220. So I move from 0 to 200. There is no guarantee that I'm going to hit the 220 in there. However, when I move from 200 to 240, because 220 is in between those numbers, I know that I have to hit a 220 on that time interval from 12 to 20, so that's 1. And again, when I move from a velocity of 240 to a negative 220, once again, I have to bypass that 220. So that's 2 times that I'm going to hit a velocity of 220. I use an inequality to represent that 220 is in between v of 12 and v of 20. Therefore, I know v of t equals 220 on that interval. And also 220 is between v of 20 and v of 24. In this region of my table. Therefore, I know I'm going to hit that 220 on that time interval from 20 to 24. And also make sure you answer the question. I want to know how many times, so I'm going to say 2 times. And that completes this problem.